Picture yourself by the coast, the salty breeze in your hair, and the rhythmic sound of waves crashing against the shore. You're watching the usual parade of ferries and fishing boats, their hulls cutting through the water as they go about their daily routines. Suddenly, something wild appears on the horizon. A boat, but it's not like any you've seen before. It's hovering above the water, gliding effortlessly on thin, almost invisible struts. It's not science fiction, it's a hydrofoil. A boat that seems to defy gravity and actually flies above the waves. Normal boats slog through the water, fighting drag and resistance every inch of the way, leaving churning wakes behind them. Hydrofoils, on the other hand, rise above it all, leaving only their slender foils submerged, slicing through the water with minimal effort. The result? Speed, lots of it. Hydrofoils can travel at double or even triple the speed of traditional boats, making them a marvel of efficiency. It's the kind of thing you'd expect to see in a Bond film, but this is real-world engineering brilliance at work, not just movie magic. The first time you see one in action, it's mind-bending. The boat lifts, glides, and suddenly it's more plane than boat, soaring just above the surface. The noisy, splashy ride you expect is replaced by a smooth, almost silent flight, as if you're floating on air instead of water. It's spectacular to witness, and it makes every other boat look ancient, like relics from a slower, clumsier era. But this isn't just for show. Hydrofoils truly rewrite the rules of marine travel, opening up new possibilities for speed, comfort, and efficiency. Why plow through the water when you can simply fly above it, leaving barely a ripple in your wake? The hydrofoil is living proof of what happens when engineers dare to ask, what if we did it differently, and then make it a reality? And a boat that flies, part vessel, part aircraft, is, without a doubt, one of the greatest and most inspiring machines ever built. So what exactly is a hydrofoil? It's a boat with underwater wings, foils attached by struts. At rest, it's just another boat, but as it accelerates, water flows over the foils, generating lift. The hull rises out of the water, balancing on the foils. This changes everything. Instead of dragging a hull through dense water, only the slim foils remain submerged. Drag drops by up to 80%. That's the secret to its speed and efficiency. A hydrofoil is more than a boat. It's an engineering hack, a loophole in naval design. It's like sprinting on stilts instead of slogging through mud. Simple in concept, but it transforms how we move across water. Hydrofoils are a leap forward in marine travel. To understand hydrofoils, imagine airplane wings, just operating beneath the surface of the water instead of in the sky. The concept is surprisingly similar, but the environment is completely different. An airplane wing's curved top and flatter bottom create lift as air moves faster over the top, generating a pressure difference that lets planes soar. Hydrofoils use this same principle, but swap air for water, a fluid that's about 800 times denser, making the forces involved much greater. As the boat picks up speed, water rushes over the foil, creating low pressure above and high pressure below. This difference in pressure lifts the boat's hull out of the water, almost like magic. Even relatively small foils can lift impressively heavy boats, all thanks to the density and power of water acting on the foil's surface. But there's a catch. The boat needs to reach a certain speed before it can take off and rise above the water's surface. Once the boat is foil-borne, drag drops dramatically and speed increases rapidly, letting the boat glide almost effortlessly. The real magic is in efficiency. After takeoff, the engine doesn't have to work as hard, so it saves fuel, reduces emissions, and makes for a quieter ride. Takeoff is the challenging part, but once cruising, the ride is smooth, stable, and surprisingly comfortable, even in choppy water. It's a brilliant use of physics, transforming what was once a slow, bumpy boat ride into something that feels almost like flying. The design is simple, elegant, and incredibly effective, blending beauty with function. Hydrofoils are a true masterclass in engineering, requiring precision and creativity to perfect. They make water travel not just faster, but smoother, smarter, and more enjoyable for everyone on board. The biggest perk of hydrofoils, it's all about speed. These boats are designed to slice through the water at incredible rates, leaving traditional vessels far behind. While conventional boats hit a wall of resistance and get slowed down by waves, hydrofoils simply rise above it, gliding smoothly over the surface. A hydrofoil ferry can cruise at 40 knots, much faster than a regular ferry, making journeys quicker and more efficient for everyone on board. With less drag, hydrofoils need smaller engines, which means lower fuel use and a much smaller carbon footprint. They're not just fast, they're smart and sustainable. It's like having a supercar on water that's also fuel efficient, combining luxury, speed and responsibility in one sleek package. Comfort is another huge win. Hydrofoils glide above the waves, so the ride is incredibly smooth. Drinks stay unspilled, and you can actually enjoy your journey. Passengers arrive relaxed, not seasick or tired, ready to start their day or adventure as soon as they step off the boat. Hydrofoils also create minimal wake, which helps protect riverbanks, wildlife habitats, and other boats from disruptive waves. That's why they're ideal for sensitive environments and busy waterways, where preserving nature and safety is a top priority. Faster, greener, smoother, and more comfortable, hydrofoils really do tick every box for modern water travel. It's a win for speed, efficiency, and the planet. Why settle for less when you can have it all? Hydrofoils are the future of fast, clean, and comfortable water travel, setting a new standard for what's possible on the waves. Hydrofoils aren't just toys for the rich or racing fanatics. They're workhorses used for high-speed ferries in cities like Hong Kong and Naples, slashing commute times. In sailing, hydrofoils have revolutionized races like the America's Cup, turning yachts into flying machines. The military saw their potential too, building missile boats that could outrun threats. Today, hydrofoil tech is everywhere. Electric surfboards, personal watercraft, even luxury tenders. Companies like Candela are making electric hydrofoil boats with impressive range and zero emissions. Hydrofoils are no longer niche, they're mainstream. From public transport to recreation, they're changing how we move on water. Fast, efficient, and now accessible to more people than ever. The flying boat is here to stay. Building a flying boat takes precision. The foils, underwater wings, must be strong yet thin, often made from carbon fiber or titanium. Their shape and angle control lift speed and stability. The hull matters too. It must be light, strong, and able to handle takeoff and landings. Struts connect foils to hull, balancing strength and hydrodynamics. Longer struts mean smoother rides over waves, but more drag. It's a delicate engineering dance. Modern hydrofoils use computer-controlled systems for stability. Sensors and computers adjust the foils in real time, keeping the ride level and safe. Early hydrofoils were tricky to control. Now they're smooth and user-friendly. It's aerospace tech on water. The result? Fast, stable, and safe flying boats. That's the magic behind the scenes. Flying boats face real challenges. Stability is tough. Balancing tons on skinny foils isn't easy. Early designs used V-shaped foils for self-stabilizing, but they're rough in waves. Fully submerged foils are smoother, but need constant computer adjustments. Rough seas can cause the hull to slam or foils to lose lift, called ventilation, leading to sudden crashes. Underwater obstacles are a big risk. Hitting debris at speed can rip off a foil. Hydrofoils work best in deep, open water. Engineers design breakaway foils for safety, but risks remain. It's a high-tech balancing act between speed and safety. Even the best flying boats have limits. Hydrofoils aren't new. The first patent was filed in 1869. The real breakthrough came in the early 1900s with inventors like Enrico Forlanini and Alexander Graham Bell. Bell's HD4 set a world speed record in 1919, hitting over 61 knots. The 1950s saw the first successful passenger hydrofoils, sparking a golden age, especially in the Soviet Union. The fastest hydrofoil, a wind-powered craft, hit 75 meters in 2012, The US Navy's USS Plainview topped 50 knots. A single square meter of foil can lift over 7 tons at speed. Hydrofoils have always pushed the limits of what's possible on water. From wild experiments to workhorse ferries, they've made history, and they're still breaking records today. The future of hydrofoils is electric. Electric boats struggle with range, but hydrofoils cut drag by 80%, making long-range fast electric boating possible. Companies like Candela are already delivering electric hydrofoils with real-world range and zero emissions. Urban transport is next. Fast, quiet hydrofoil ferries could transform city commutes. Imagine flying over rivers instead of sitting in traffic. Projects are underway in cities like Paris and Stockholm. Hydrofoils are about working with physics, not against it, delivering speed, efficiency, and elegance. As materials and tech improve, their uses will only grow. From eco-friendly ferries to high-speed cargo, the sky's the limit. After a century, hydrofoil's golden age may just be starting. The future of water travel, it's in the air.